So it is time to start our case. So all what we did was to get the relevant references of my circuit and all its components to be able to create the case. So let's start the case. Let's create a new construct. Let's create a plane right here. Let's give it 4 millimeters. It's fine, 4 millimeters is fine. So now we will create a sketch on this new construct. We will call it renew top case top plane. So here we need to create a rectangle. So the device should have walls. My idea is that the device should be assembled into the case should be assembled in two pieces. So two walls together. So like this. So this is gonna be one half of the case, and this is gonna be one half of the case, and it's gonna be assembled like this. Why? Because this is gonna allow us to play better around with the components. That's my theory. Hopefully it works. So because if not, it's gonna be difficult to assemble the device. And you know what? That makes me think. The thing that I just told you, that makes me think that the battery shouldn't be there. Because if I want the battery to be connected, I think would be more convenient to have the battery in the bottom. So we have two parts, only two. The case will be composed of will be constituted by only two parts. Each part of it will have three faces. The top and two sides, and the bottom and two sides. So in only one piece, all the components are gonna fit. I think that approach is gonna be better. So whenever you unassemble, you can unassemble and just take, for example, the leaf that doesn't have any component on it. Because if you try to separate them, whenever you have the battery, in this case, for example, in a parallel wall, whenever you separate it, whenever you unassemble the device, you might pull the cable of the that connects to the battery. So I think it's gonna be better if we move the battery to the bottom. What do you think? Let's move the battery to the bottom. So we can actually see. I think it's gonna fit. So what we can do, this sketch. So this is the top. Let's rename this sketch so we don't forget the top sketch. Case top sketch. Okay, so let's go and copy the battery sketch. Actually, what we can do is just click copy, finish sketch. We can go back. We can go to the bottom, and we can create a plane right here. So we can create another construct that will be a construct where we will use this. We need a plane, and what's going to be the distance? So we can go here and kind of like move it and see, maybe 4, maybe 3 millimeters. But it's going to be 7.4 millimeters, right, for the battery. Let's try to do the 23 millimeters. I think that's okay for that plane. So we have plane 4, and on the plane 4, we're going to create another sketch. Let's try. Created the sketch. So we are going to delete that, and we're going to paste this one. We're going to move it. Even it might actually fit under. Oh, we can rotate. Let's rotate it, and let's see where it fits. Actually, it fits perfectly here. Yeah, it fits perfectly here. So it's not going to collide with the speaker. Actually, we can extrude and go up. Yeah, it's perfect. Yeah, now we just need to extrude again. We're battery. Finish sketch. Now we're gonna do minus 7.4 millimeters. There you go. Now we can delete our previous battery. Let's delete this one. Now let's rename this one battery. Now this plane is renamed battery plane, and this is gonna be also the case bottom plane. That's gonna be cool. Okay. Yeah, we will be able to reuse this plane whenever we create. Actually, we can start from the bottom, from this actual plane. Why? Because this side of this new volume that we're going to create is going to hold all the components, and the other one is just going to be the cover. So let's do it into parts. Okay, so now we will create another sketch on this plane. Yeah, there you go. Let's test that we're in the right plane. Sometimes the thing is, sometimes one can get very confused. Okay, yeah. We can revert that and start creating our case. So let's see how we're gonna do it. So from this, what is this? From here, so these are the references that need to be cut through. These shouldn't be at the same level. Why? Yeah, so these shouldn't be at the same level. Okay, so I'm gonna let you know why later, but let's go and check this volume. This volume is part of the recording device. This volume is part of the recording device. So let's repeat this. Finish the sketch here. Let's edit this feature. This is 16 millimeters. Now let's do it 20 millimeters. But you will see why, because I wanted to go through the wall, and actually the inserts should have a little more wall, a little more thickness behind, because you don't want that the insert just go all the way through. You want some wall behind. Yeah, you want some wall behind the behind the insert, at the end of the insert. You will see why. So now I think we are okay. So now we're gonna create. We are gonna go back to my sketch here. I think it was this. So we're gonna rename it as case bottom. So now we're gonna create a line. Oh, no, sorry. We're gonna create a line. We're gonna transfer this line. So from here, I want maybe 2 more millimeters of wall. Yeah, I think the best thickness for a wall should be 4 millimeters, maybe. For the device, maybe 3 millimeters. 3 millimeters is fine for a wall, I think. Now let's do it 4. Why not 4? Let's not be cheap with the plastic. Okay. So what we're gonna do is, now we have the measurement from here. Okay. So now this one is gonna have 2 millimeters towards here. This one is gonna have 2 millimeters towards here. 2 millimeters. Okay. So what does this mean? Is that this is gonna give me the reference of the outer wall of for my device. So my outer wall should be here. The outer wall. Yes. So now from here, I think should be okay. Somewhere here. Right here. Oh no, let's repeat that. So I want that this USB port is a little outside. There you go. Yeah. Okay, if we look at this, this will be the base. I think let's do this one here as well. Let's add to the speaker hole. Why do I need the references for the holes go so far? Because whenever I create the volume, I think there's an operation that is gonna respect those references, and it go around those references instead of creating the volume. So I will cut those spaces out of my actual volume, so I don't need to copy again those references and do the extraction of that of the solid again. So I don't need to cut the solid. So it's gonna do it for me. So it's gonna be automatic. So that's the idea. That's why I'm so interested of the references go through the walls. Okay, so this is one. Okay, let's finish this sketch. Let's edit this one. Let's do 10. There you go. Now I have these. Now I need the inner walls. So from this sketch, what I'm gonna do is also gonna create the holders for the battery. So I'm gonna copy the references of that battery. Okay. I'm gonna copy the reference of the battery so I can create the battery holder. So I want to try something. Let's see if I can. Let's see if it works. So from here to the half. Let's see if my idea works. I always wanted to have like a where you just introduce the battery and you snap it. So let's make something like this. Wait a second. But let's give it some tolerance. Yeah, you don't want to always have like everything so close, so we are gonna give it some tolerance. Yeah. Then we will go here. This one. No, sorry. One a little twisted. Then go 0. There you go. Sorry. There you go. So now we can delete this. We can delete this line. We can also delete this line. Now we can mirror this 1, 2, 3, 4, 5 lines. We can use mirror, select this one. Okay. We can trim this line, and there you go. We have one piece of the folder, and then we are gonna have another folder here. No, let's do this. No, wait a second. No, what we can do is something like this here. Now, from this one, we have something here. To here. Okay, like images. There you go. Yeah. Actually, I want to move this line a little further. There you go. There you go. Okay. So now we can finish this sketch and we can extrude this. So I'm going to extrude this thing. Extrude it somewhere here. Okay. Now let's so in this case, for example, I don't want to see this, and I want to see this, and this, and this. So I can focus only on this one. So what I want to do now is to create a small sketch here on this wall. And I want to see the battery as well. Battery, and these are the battery case bottom. So now here I'm working on this one. Also, I want to see battery, and maybe I want to see this. Well, I want to see actually the battery. Yeah. So what I want to get is somewhere here, because now I want to extrude this. There you go. Now I want to see this, and then I want to extrude this. So this is going to be my battery holder. So hopefully with this, the battery doesn't move. I know that the risk here, my experience will tell me that the 3D printer is not going to shift this move. That's what I think. So let's see, because I think this didn't work as I expected. So cancel. I need to modify my sketch actually. Now we extrude here. Join. So I think I still need to change this. Join. There you go. There you go. There's my battery holder. Now I need to see the case button, because I'm going to extrude also this back part, but I need to see the case button. So I'm going to extrude. I'm not being very exact with this because I don't think I need to. There you go. Now here we're going to do something very fun. So here we're going to do it a little more like this. And in order to print this easier, we're going to do something a little crazy. We're going to go here and create a sketch on this side. And we're going to create a triangle like this. A little triangle like this. So this should keep the battery in place. Also, what we are going to do is extrude this and leave the corners to object. There you go. Join. Also, I'm going to change a little bit this sketch because I want to leave the corners without covering. Because if you look at the battery, the corner, one corner has the cable. So I want the flexibility to flip the battery as needed. So we can, I want to move it. I want to delete this constraint. Now I can do it. There you go. We don't need to be very precise for that. And I think we got this. Let's see. Okay. Yeah. Now, the only thing that we need to do is to repeat this volume edit feature. There you go, to object. So to object is gonna we select this face and it's gonna extrude up to this face and join. And now we have our battery holder. Also, we're gonna do something to be able to print this correctly. We're gonna then modify this sketch. Let's see how we can modify this sketch. Well, this sketch is, we're gonna rename it as battery bottom tip. And this we're going to rename it as battery top holder seal. Okay. Now we're going to change this sketch. So what I want of this sketch is to also have this kind of thing. So I want to have no, this is not bad. Okay, this is too small. So we will need to repeat this. Finish sketch. We will need to repeat the extrusion of this. this feature. Let's do 10. Yeah, I think this is gonna be better. We do this. Let's say 9 millimeters. It's okay. Now we are gonna this volume. We're gonna call it like battery holder button. This we are gonna combine these ones. With this, we can combine two components. Well, we will be able to do that until we create a case, but it's fine. Now we are gonna modify this sketch. This sketch, we are gonna change it to something like this. So why? You will see. Now there's an angle where it's gonna be easier for the printer. It's gonna be easier for the printer to print this ceiling. So without this, the printer can like just try to print on nothing, and it's gonna be messy. So it's better. Most of the time, it's better to keep angles on the overhangs. So over here. Oh, there you go. We didn't lose it. Okay, so I think this was one of the most complicated parts, the battery holder, but we got it. Now, we can extrude the walls. Now, it's the moment to extrude the walls. Let's see if what I was thinking works for the references. So, this is gonna be these walls. We are gonna modify this. This is the case. We'll modify this sketch. And we are gonna use the offset. And we said that we want 3 millimeters walls. No, let's do more. 5 millimeters walls. Like that more. I like that way more. Okay. Oh, that's 4 millimeters. I like that. Okay. Now we're gonna extrude the walls. Oh well, but this is gonna be only 2 walls. Yeah, this is gonna be only 2 walls. Why? Because sketch. No. Because we only want 2 walls. But actually, yeah, this is fine. Okay. Yeah, and up to here. Yeah, these are gonna be our walls. And we're gonna eliminate this line, this line, this line, and this line. I think so. Yeah, that should be done. Sorry, we shouldn't eliminate a couple of walls. Sorry. There you go. We should keep. We should eliminate this one, and we should eliminate this one, this one. Why? Because we have the base. Wait. Why? Yeah. Why? Because I have to do this one. Wait. Where does this line get up to? Oh, here's the line. Yeah. Okay. So up to this here. Okay. Yeah, I didn't have that line, so we can eliminate these. We can eliminate these, and we can stay with this. Okay. So as I told you, we are gonna create 2 walls on each part of the case. So the case is gonna be it's gonna have 2 parts, like a bottom part and a top part. So we are working on the bottom part, and the bottom part is gonna have 2 walls. Now we are gonna try to create a solid. And there you go. No. New body. Okay, didn't work. Actually, we're gonna need to cut it, but don't worry, I think I have an idea to do this. I think I have an idea to do this. Don't worry. So I think that's gonna be okay. Okay. Yeah, let's say 105 millimeters. Yeah, that's fine. Okay. Now we are gonna do the bottom. sketch. We're gonna remove this line. Now we are gonna create a solid towards what you're gonna include it, you're gonna include it, you're gonna include it. And then now this one is gonna be 5 millimeters. Oh, 8 millimeters. We don't need something so thick. Yeah. I think this is fine. Okay. Okay. Yeah, this side. Okay. So, for example, we're gonna cut. We can take this one, and to cut through these walls, we can edit feature and do a cut. Objects to cut. Cancel? No. I'm pretty sure I can. Yeah, I can move this one here. Yeah, I can move it through the history. Edit feature and cut. There you go. And voila. Now we just cut through our body. No, that was very nice. But let's keep moving with the eyes of our ultrasonic thing. Okay, we can do the same. Actually, we can edit this feature. We are gonna do it like this. We're gonna just increase the distance and cut through. It says there, there's no object to cut. We select it, and there you go. Now we just cut through our wall. We can repeat this process with this. Okay. If you look at this, when you select the volume, it indicates here with these 3 lines which is the one that you have selected. So let's move towards the end. We can edit feature and we can select cut objects to cut body, and there you go. Now, as you can see, there's a space. There is still a space here. The thing is that we need to actually cut through the walls to have those. So let's do it. We need also those ones to be almost here. Cancel. Let's move them almost to the end. Cancel. Move it to the end. And these ones, this volume to the end. So with this feature, cut. Looks to cut. Objects to cut. Edit feature. Cut. Objects to cut. Body 16. The body 16 is actually rename it as our. Now, actually, let's join them now, because now we can join them. Let's join them. Let's join all those geometries. Actually, it didn't join them. So we select the target body, and then we select this one. And so I think, okay, I think this is. I think this happened wrongly. Where's the battery? The battery. This. So let's delete this one. Let's delete this one. Now the battery. How can we split the battery from the button? So let's change that extraction. Yeah, this extraction. edit feature, instead of join, new body. There you go. Now it is a new body. So you have the body 19. Still, oh yeah, there you go. So now use this one, this one, this one. So now we're gonna join everything to this. Now this one, and this one. Now they are all joined in body 19. We're gonna rename it like case button. And there you go. Now we have almost everything except for this one. I'm gonna do this one and cut. Good. There you go. So now I think we have everything that we need. No, there's something I don't like. I need these ones to go a little more. Because if you look at this, there's too few. But what I was thinking, we will need to take a cylinder out. This is gonna be very complicated because if I print like this, it's gonna be complicated because since it is a very small amount of material that needs to go out to cover the insert, yeah, it's gonna be complicated to print that because of the overhang. So what we can do is extrude the material and try to fill it around and see if that can help, or maybe just do like what we did with the triangle previously. What we're gonna do is gonna try to accommodate some material to hold better this the insert. To achieve that, we will need to do something very tricky, very sketchy. And it's going to pull up. Actually, when you see some cases for devices, you see that the inserts, or where the screw goes, they pull it a little off from the face of the case, of the inner face of the case, to accommodate the screw. So we're gonna do the same. Yeah, but since it's gonna be complicated because of how the printer, because I'm gonna try to print it on this like this in vertical. So yeah, it's gonna be a little. I don't want to use too much support. And even with support, it might make it a little complicated. So let's try to make these the holders for the insert. So what we're gonna do is create a new sketch. So we're gonna create a new sketch here. This face, and this is gonna be very, 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 very simple. So we're gonna remove this. We are gonna maybe the recording device. No, actually, let's remove the speaker, the ultrasonic board, and let's leave this one. So what we're gonna do is gonna be a square, but let's see how we can do a rectangle, a center rectangle. So we're gonna use a center rectangle for this. Our center rectangle is gonna be, I think this circle is 2.8 millimeters. So it's gonna fit in a 2.8 by 2.8. So the square should be something around, let's say, 4 millimeters, maybe. Let's play around with it. I think this is fine, 4 millimeters. So let's repeat that process. It's double enter 4 millimeters, 4 millimeters, 4 millimeters. For this, I guess it's gonna be bigger. Maybe 5 by 5. I like it, 5 by 5. Rectangle. 5 by 5. Rectangle, center rectangle. 5 by 5. Let's do the next one. 5 by 5. Okay, so we have, like it. Now we'll create a solid from this. But now I want to show the speaker. So let's here. I want to show this. No this. Don't show any plane. Don't show anything. Let's not show the speaker yet. We will use the speaker, but in a moment. Oh, yeah. There you go. Which is this? Which is this? Which is this? Now, we're gonna show the speaker now, because what we're gonna do is to object. And what's gonna be the object? The speaker. So to this object. Maybe join. Yeah, it's gonna join. Object, direction, on side, selected. Extend type to object. Start profile plane. Yeah, and I need to select the object. Let's confirm. Yes, I think that's exactly what I wanted. Mm-hmm. Okay. Okay. I think that's exactly what I needed. But now, the complicated part comes to play. How to do it, not a critical overhang. So to not do a critical overhang, I think we will need to create a new sketch. So let's see what sketch these are. Then edit. Yeah. This is gonna be the insert holders. Uh, front wall insert holders. Now we have this, we have that. Now we are gonna figure out this. Figure out how to make it not critical. The thing is that this is gonna be kind of complicated because of this, but let's try it. Let's see. Let's see, we can do it. So now we are gonna create another plane. We do like this as well. Yeah, we're gonna use some other features. So now we're gonna create a sketch here. So we're gonna create triangles, simple and basic triangles. I think 45 degrees will be okay. 45 degrees, I think it's a good one. So we're gonna copy that triangle. We're gonna copy it. Oh, come on, there you go. And now we have triangle. Okay, we have two triangles. We're gonna create another triangle here. Now we close the triangle. And here, there you go. This is our triangle, and we're gonna copy this triangle. Okay, I lost the audio here again due to my microphone, so the audio is gonna be separated. So here we continue copying the triangle to all the extrusions for the inserts. Okay, now we set the triangle in the corners of the insert volumes. We need to zoom in a little bit so we can catch the corner because it's not transferring to the sketch. So we finalized the sketch, and now it seems that whenever we extruded the volumes for the inserts, since they ended actually in the speaker became the main volume, and everything that was connected to the volumes got attached to the speaker. It joined the speaker volume. So here we are trying to separate the volume. So we will go back in the timeline, and we are gonna redo the joining. So we found the action. We are gonna edit the operation, and we are gonna create a new body instead when creating the volumes for the inserts. So once we separate it, now we can join them to the correct volume, that in this case is the case button. Now you can see that we have the insert volumes joined to the case button. Now we are going to hide the unnecessary volumes, and in this case is the speaker and the board, the ultrasonic board and the circuit board. Now we are going to extrude the triangles from the beginning phase of the inserts to the end phase of the inserts, to the opposite phase of the inserts. Now, as you can see, the corner kind of got in the way of the circle of the ultrasonic sensor. So what we can do is actually include that volume in the ultrasonic sensor cut reference. But we're going to do that later, whenever we finish adding all the triangle volumes below all the insert volumes. Now we are going to go a little quicker. So because we are going to just repeat the operation at all the inserts volumes for all the triangles. So now we want to apply the cut operation, the cut feature, to the extractions of the inserts. And we did this by moving the operation after the operation of extruding the triangles. So we move it kind of at the end. You will not see it very well because I have the video there, but I move it to the end. So I look for the cut operation, and in the timeline, I move it all the way to the end. And I am going to do the same for the cut operation of the speaker. So I'm going to go to the timeline, and I'm going to look for the cut operation based on the speaker reference that we created that crossed the volume. And what we do is move it to the end, passing the creation of the supports for the insert volumes. And as you can see, now it actually cut through them as well. Now we are going to go and rename the triangles as the front wall overhangs. So these are the overhang support for the inserts volume. So this is going to facilitate the printing of these extractions for inserts. Now it is time to add the volumes for the inserts in the side wall where the recording device is going to be. So let's create the rectangles from the center of the circles, 5 millimeters as before. And we are going to repeat this for each circle. Now we select the 4 volumes of the inserts to extrude them. We extrude them at 3 millimeters. Well, no, we're going to go back and change that to 3.5 millimeters. Now we are going to create the overhang. So this process, we have already done it before. So we snap the line operation to 40 degrees, and from the corner of the insert, we pull the line to the wall. And we close our rectangle, and we copy this rectangle to the bottom inserts, so we can extrude the overhang for the 4 inserts. It is time to extrude the overhangs. So this operation is exactly the same as the ones for the front wall. So I'm gonna speed this up a little bit. So now we have the overhangs for these inserts, but we are having the same problem as before. We need to pull the cut operation to be after the creation of the overhang volumes. So we are going to pull it in the timeline all the way to the end of the timeline, or at least after the creation of these overhang volumes. And once this is arranged, we will be done with our first part of the case. And now we are ready to print. This is a time lapse of the printing in the Bamboo Lab P1S. I finished the print. It didn't look bad, but there are some improvements that I want to do. I want to add the inserts for the top part so I can screw it to the bottom part as I show here. And also the ultrasonic sensor didn't actually fit very well to the holes. So I need to add some like 0.2 millimeters of tolerance in the distance between the eyes and the size of the holes. For the battery, it didn't fit as I would like to. The battery has this little plastic that didn't fit very well, but it is also a thing of just adjusting 2.3 millimeters. After printing, I compare and I tried to fit the components into the case and noticed that they don't fit. But remember, there are no mistakes, only happy accidents. No worries, this is all part of the process and gaining experience. Being experienced, it is not about avoiding mistakes entirely, but about reducing the accumulation of flaws when designing. The best way to do this is by testing as soon as possible. My recommendation would be don't get too far ahead in your design without testing first. In my case, I try to split the case into manageable parts to minimize the accumulation of flaws. By this way, I could address any issue with a single print and reduce the wasted material in a way. As you design more and more, you will learn when it is the right time to pause and test. Sometimes you can even create a quick design to validate your measurements. If you would like me to create a video dedicated to that, let me know and I will make it happen. Okay, so I recorded the measurements that are wrong into an Notion page. So let's jump into it. The first thing is the ultrasonic sensors. The ultrasonic sensor circles were a little too small. So we will need to increase the size of the circles and increase the separation between them. So let's go ahead and search the sketch of the ultrasonic sensors. So we can come back here. We want to now modify this sketch. So we can create a dimension to separate both sensors. That's one measurement that we need to fix. Instead of 25.3 millimeters, I want to do it 25.8. 0.8. What happened here? What happened is that this moved, but the only one that moved was the one in the right. So here we will start seeing problems because I didn't create constraints from the beginning. This is a very important thing to do in your design. Is always trying to create as many measurement constraints that you can. A way of doing it is as you saw here. I'm gonna remove it and we'll go back. And a way that we can achieve this without actually going and redoing all the work is by creating a line here. And we will need to do this twice and then we can mirror again. So what we can do is we can delete this and we can create I think with this we can create how is it called? A sketch dimension. I call it measurement constraint, but I think it's a dimension. So let's increase this by 25. So if you don't want to do the math, you can always let the software do it for you. So now that we have this, we can go and also we can change the size of the circle right away. So here is 15.7, but we need 0.5 more. So let's do it 16.2. Well, let's just do this. Oh well, but it needs to be 0.5 divided by 2. So let's even try that. There you go. Perfect. So it did it for us. So now we will use this and this and this. And there you go. Now we have constraints. We have our dimensions established, and they are going to be I don't know how to call it in a different way, but unmutable. So we cannot mutate them. We cannot change them unless we go there at the end and delete them or change them. Yeah, I will keep that line. It doesn't affect the actual design. It's just usually what you see in the sketches doesn't translate to the volumes unless unless you actually create a volume from there by extruding. So now that we have that measurement fixed, we will fix the insert holder. So this task is going to be a little more, I'll take more time because we will need to fix many of them. So we're going to hide the ultrasonic board. We are going to hide the sensors and we are going to try to increase the size of this. So let's see if we can do it all in once. So I think I don't want to go and search for the sketch. So is there a way that I can go and modify that sketch? Let me see. No, I don't think so. I mean, I think I don't. I think there might be, but sketch. No. Let's go and try to modify it. Let's try. Let's go and search because I didn't find a functionality that does that. I might research later that. This was the what? What do I find? These holes. Oh, I think I know why. They might exist on this volume. No, they don't exist there. We can look for that volume by going to our. There you go. The holes. Who made those holes? Front wall to insert holders. Let's insert holders. Let me hide again the ultrasonic board. Yeah, it is this one. So the front wall insert holders. So now we are going to increase the size. So we are going to set sketch dimension. We have 2.8. So we will increase it to 3 millimeters. We'll finish the sketch. So we can go the ultrasonic insert and change this. There you go. So now we can actually change this. We're gonna have this is gonna be 3. Now we're gonna repeat that process to this, to this, to this. So sketch dimension. Sketch dimension is gonna be 3. Sketch dimension is gonna be 3. And the sketch dimension is gonna be 3. There you go. So now the diameter of the holes is 3 millimeters. So we're gonna go and also modify these ones. This is the speaker. Let's see if it is this one. No, it's not this one. So we will need to find the inserts for the speaker. Let's see if it is this one. Okay. No. See, let me find a way to actually go and change that, but we need to hide the speaker. And we need to find in browser. Okay, yeah. So whenever I found a way. Whenever you select something, it's gonna get selected in your timeline. So that timeline proved to be very useful again. Oh, I'm a little concerned. Is this at the same? Is this aligned? Yeah, it is aligned. I am just making sure this is aligned. 90 degrees, yeah, it's aligned. Maybe because of the image here, it's changing my perspective. Maybe this guy deceiving my side. Not sure, but it's fine. So I select this and I change the constraint. Change the dimension. Let's change it to. Okay. Interesting. Nice sketch. Oh, okay. So these lived in the speaker actually. So sketch dimension. No, they don't live in the speaker. Okay. It's not that they don't live in the speaker, it's that they already have a constraint. That is the problem. Okay. Let's change the size of this. No, we want to change the external one, not the internal one. There you go. Alright. Changed. Click finish. So now our 3D model changed. But now we want to change this square. Now we can go to the sketch here. I want to add 0.2 millimeters also to this. So 5.2, 5.2, 5.2, 5.2. Why do I want to add that 0.2 to each side? Is because it is because if I don't change that, the wall is gonna be very thin, and I don't want a thin wall holding the inserts, because whenever I heat up the inserts, the wall can get messed up. So we don't want that. Okay, I think should I change also this word? Let me see if I also need to add a dimension. 4.2. There you go. 4.2. 4.2. And 4.2. There you go. So now we have the correct dimension. So let me make sure that this is symmetrical square. So same constraint for the height and the length of the square. Okay. Now we want to also fix the inserts right here. Maybe I'm gonna just skip this part in the video because we've already seen how this is made. But anyways, in case I want to keep it in the video, I'm gonna the recording device. I'm just gonna try to change this one. I don't see it in the timeline. Should be the sidewall insert holes. There you go. Well, we will change this one first. 4.2. 5.2. 5.2. 5.2. 5.2. Okay. So now I'm gonna also add a sketch dimension, but here this dimension doesn't live in this sketch. So let's find out from wall. Most likely this lives in the recording device. No. So where do these live? Nope. Recording device inserts. There you go. So this one already has a constraint. So 4, 4, 4, 4. Okay. And the battery. So the battery holder. We need to also change this thing. At the bottom, the sketch of this needs to go a little away from the battery. Why? It is fitting, but the battery is like getting a little scratch. So it has like a thin plastic wrapping that is getting stuck into this little corner. So I need to move it a little further back. So let's try to move it away. So we need to change the sketch. So that sketch should be the case button. So let's go and change that. So, okay, why can't it's case bottom? Oh, is it top? Battery holder ceiling. Let's see. Nope, that's not the thing. Maybe sure it's this one. Okay, that's a huge opportunity area. I need to improve the naming of my sketches. Did you sketch? There you are. It was the case button. So now, let me see how I can avoid that. Okay, so I think I will need to select. How do I select this? Yeah. No. I need to move it. See if I can select. Why is not letting me select? What does this mean? Oh, this is the user interface change. So now you can, okay, no, you can select by, okay, I select that, modify, move, can I move? No, well, let's set the pivot, cancel, let's try to move it again, let's unselect this, and let's put it move and copy, there you go, there's it. 1 millimeter is too much, so maybe I want to move it 0.5 millimeters, 0.5 millimeters. Yeah, I think that should be enough. That will do. Okay, so now we just fix our design. Okay, so also the walls are a little too thin. Maybe not too thin, but if I want to use inserts to hold the case, that's gonna be a problem because the walls are too thin to hold the walls, to hold the inserts, to hold the other part of the case. So I'm planning to use bolts with inserts to keep the two pieces together. It's not gonna be very clean, but at least you will see how to do those inserts in the wall. I think it's gonna be enough only with 2 of them. So what we're gonna do is we're gonna extrude some material from each corner of the case, and we are gonna add an overhang of 45 degrees as the same as the other inserts, but we are gonna create holes in the top. on the top. So the other part of the case goes on the top. It gets screwed to these inserts. So we can go and modify. How are we gonna do it? I think the best option. No, I think the best option is gonna be front, the right. Yeah. So the inserts are approximately 3 centimeters, 3.3 millimeters. The inserts need to be 0.6 centimeters deep. So we will need to have maybe 7 centimeters of material hanging. So let's go and modify and create a new sketch on this wall. So we are gonna create a rectangle here. We say, no, it's one corner. So, I'm not getting the corner. Okay, yeah, I'm getting the corner now. So it is gonna be 7 millimeters by 4.2. There you go. We have our rectangle. Now we're gonna extrude that, but we already have some material. So if we look at this line is 4 millimeters. So we said that it's gonna be 4.2. So we want 0.3. Let's do 0.3. So we have enough space. 0.4. I like even numbers. So this will add enough. Now the problem is that this will require some material in the overhang as well. So we will create another sketch here, only for the purpose of having some overhang. Let's get 45. Let's get 45 degrees overhang. And remember, don't press enter. What you need to press is tab. So it's 45. And we can move it. There you go. Now I think let's try to create a solid from there. Yeah, we can create a solid actually from 2 different sketches. From the sketch line and the actual projection created by the volumes, you actually don't need to create a whole triangle. That's very nice. I didn't know about that feature. So we will repeat from object to object. So the object is this face, and we are gonna go to the next object that is gonna be the face in the other side of this volume. Well, we have the bug, but we already know how to fix it. So in the middle, yeah, there you go. I love that solution. I hate that bug. There you go. Now we have our overhang. We are almost ready to create our hole. We can go and create our hole here. How are we going to create a hole? So we need to create another sketch. For the insert, let's create a line here to the center, and I'm going to create another line. These are only guidelines because I want to go get the exact center of this. I want to get the exact center. Oh, yes, in the center. 0.2, 2.2. There you go. So now we can create our 4 millimeters. I think this is not what I wanted. Why? I think it was 3.8. Oh no, the diameter was actually 3 millimeters for that one. So we will repeat this one. We actually don't need to repeat it. We just need to change this to 3 millimeters. So now we have a considerable amount of material to the insert, for the insert to expand the plastic whenever it hits up and enters the wall. So now we are gonna create a solid. But this solid, I'm gonna wait because I want to have the same depth as the one that I'm gonna create here. So let's jump and create the sketch here in this wall. But before doing that, let's rename our sketches. Always rename our sketches. So this is the insert sidewall insert material. Let's rename it as sidewall insert overhang. Then let's rename this one as sidewall insert hole. There you go. So now we're gonna create a sketch here. Why cannot create a sketch? What? Create a sketch? What happened? I should be able to create a sketch. No, I'm in sketch. Okay. I didn't know what sketch I was on, but Now we will repeat the process. So we will open this to 7 and 4.2. Just 4.2, 4.2. Now we will take this one, 0.3, 0.4. We said 0.4. Yeah. Feature. The feature. Yeah, 0.4 millimeters. So it is the exact amount, the same exact amount. Now we need to create this rectangle here. Okay. Now we need here. We're gonna say 45 degrees. Nope, 45 degrees to this direction. So now we will want to match it with this line. Now we can create a solid. That the same exact. What happened? Something is not good. Okay, first of all, what's this line? Oh, wait. The thing is that here we need to hide this one. And where's this line from? Okay, doesn't matter. It disappeared. Now we have here. Here, what's this? 1, 2, and 3, and we can create a solid. Oh well, this time we weren't that fortunate. We will need to create the triangle ourselves. Why? I don't know. I don't want to figure it out. That's a very small detail that I don't think is gonna affect anything. I hope. Here you go. Now to the other side. And to this side. Excellent. We have our overhang. Now we are ready to drill our hole. Now this is behaving in a very strange ways. Doesn't matter. We got this. We got this. Okay. We're gonna proceed with finding the corner. And from the corner, we're gonna draw a line right there. No, we're gonna do it the other way around. 4.2, it should be somewhere 2.1. 4.2 should be 2.1, right? So now we are gonna make this 3.8 circle. What was it? What was the measurement? Wait a second. I just forgot the measurement. Let's go back and try to remember. It was a 3 millimeters diameter for this. 3 millimeters diameter. There you go. And now we remove the supporting lines. Now we are gonna drill the hole. But we said that we were gonna do the 2 of them. Now we can do a 6 millimeter hole. And I need to repeat the process. Why? Because I did it wrong. It was minus 6 millimeters. What happened in the future? So instead of cutting, it joined. Now we have our holes, and I think we are ready to jump into the other part of the case. But before that, I'm gonna print this and I'm gonna validate my measurements again. But wait a second, something happened. We lost an eye. What happened? What happened was that since we eliminated the circle and we didn't assign the new circle to the extrusion, we will need to do it again. So don't worry, that's a very simple and quick fix. We just need to go to this feature and select this circle. There you go. Now we have our 2 eyes back. We have the holes for the connection with the other part of the case. We have moved our battery holder. We have increased the size of the ultrasonic sensors and the size of the holes for the inserts. So hopefully this is gonna work fine. I'm gonna print it again. Let's see if this fixes the problems. Okay, so I'm gonna show you how to import your file and print it. I'm using Bamboo Labs printer. I'm using their slicer. So the process to export is exported into an STL file. But my design has these floating components, and I don't want to print actually these components. What I only want to print in this file, and it's better if you keep your parts separated in different files. The only part I want is the case button. So I hide everything except the case button. The sketches, they don't matter. And then I click on export. I have Cat Nagger did D6. That's okay. I export it, and then I open Bamboo Labs. Then I create a new project. This is fine. No, I don't want to. Just modify these current modify values. I want to start from scratch. So now I pull my file that I store in my files, and there you go. I pull the STL file. You need to make sure that you select the STL and you save it as STL, and you import it to the right file. Then in my case, it didn't save as you saw. I discarded the change, but the only change that I make, I'm putting in PLA. It is Elson, something like that. The name of the filament that I use. So the settings are pretty standard PLA, and I'm gonna use the type 3 auto, style default, threshold angle of 30 degrees, and support critical regions only. No, I want support on everything. Remove small overhangs. I don't know if I want to do this here because I have the little overhangs I have in my screws right here, my inserts here. So I'm gonna proceed and slice the plate. And I got these beautiful trees everywhere, and I think it's fine. I could even support here. I will increase the angle to 35. Let's see what happens. Usually I don't use 35 degrees, but I'm curious about the little holes, why it's getting me the little holes. That didn't happen before, and I don't think they are needed. Let's tweak these a little and see if I can get rid of the supporting holes. Okay, yeah, by removing the small overhangs, I think it doesn't remove the ones here. I think it's validate that my little overhangs. Yep, they're intact, untouched. Hopefully this prints well. So good luck to my design. Good luck to my print. So let's print. So we print the plate. Blah blah blah. I only press OK to everything. I don't need bed leveling. It's leveled, pretty sure. And started to print. So I'll be back with the results later. The print is complete, and now I remove the supports. They come off pretty easily. In the next video, I will show you how to place the components, heat them up, and insert the inserts into the bottom case. Thanks for watching. Don't forget to subscribe so you can follow the series.